In this video, we're going to learn about the types of reactions, and I'm going to specifically go into detail about two of them to start with. So the 5 types of reactions that we'll talk about in Chem 1 are synthesis reactions, decomposition reactions, single replacement or displacement reactions, double replacement reactions, and combustion reactions. So what I want you to notice is if you look on your reference table, I just want to point this out, that on page 6 of your reference table, there is a list of these 5 different types of reactions, as well as a key that sort of gives you the general form and some more specific information about specific types of those reactions, and would help you to predict the products of those reactions. So remember that you have that at your fingertips. But let's just go into detail about the first 2, and then in the next videos I'll go over the other ones. So a synthesis reaction is also called a combination reaction, and the word synthesize means to put 2 things together or to build something. So generally a synthesis reaction starts with 2 substances that are typically elements, and they combine to form a compound. So the general form here is that you have element A combining with element B to form a compound that is a combination of A's and B's. So one example would be hydrogen gas plus oxygen gas gives us H2O water. And notice the reaction, we've got this element to form this specific compound, and then you go back and you balance that reaction. So just to give another idea, if you start with a skinny bird and you eat a worm, those 2 things would combine to form a chubby chicken. Alright, now let's look at one more synthesis reaction. So here we have 2 different elements seen in this beaker and in this round bottom flask. In the beaker is potassium. Remember that potassium is an alkali metal, and it's very, very reactive with water. So it's actually being stored in oil here. It's being protected so that it won't react with water in the air. It's very unstable. So potassium here, it's a solid metal. And if we were to react that with chlorine gas, chlorine is a toxic gas. It's a diatomic, so it's Cl2. And when we combined these 2 things together, they're typically going to form a more stable compound, and they form a salt called potassium chloride. So in this image you can see the process of the reaction happening, and right here you can actually see the formation of a gas. There's actually a bunch of heat that's given off. So remember, those are all indicators of a chemical change. Now one other thing I want to point out about the synthesis reaction is notice that we have potassium and chlorine, and we write the correct formulas for those 2 things. But then if you look at the compound here, we know potassium is a +1, chlorine is a -1, so the formula for potassium chloride is KCl. Then we go back and balance in order to make sure we've got the same amount of things on the left as we do on the right. But the most common error with these kinds of reaction and writing products is people just want to stick those 2 together and say KCl2. But KCl2 is not potassium chloride. It's not how not the actual formula for the compound. So just remember that you use your formula writing rules when writing products. Alright, the next one is a decomposition reaction. So this is just the opposite of a synthesis reaction. This is when a compound breaks up into its elements from a compound. So you start with a compound that is a combination of some amount of elements, and then it breaks down to form an element and an element, or simpler compounds. So if we look at that same example we started with last time, if we started with water, it could break down into hydrogen gas and oxygen gas. Now to give you another idea, so you've got an egg with a baby turtle in it, and that could react to form an eggshell and a baby turtle, which are the components that make up the original reactant. Now let's look at one more decomposition reaction. So this is actually the formation of mercury and oxygen gas from mercury 2 oxide. So mercury 2 oxide is our compound that we see here, and it is a reddish powder, okay? And if we were to decompose this, we would break it down into its compounds. or into its elements. So mercury and oxygen. And remember that oxygen is a diatomic, so we would write O2 gas. So these are our two products that we would have. Now, one thing that I want you to notice about a decomposition reaction is notice that the step from here to here has an addition of heat. Quite often we have to add heat in order to make these reactions happen, or some sort of energy. So if you look at the arrow here above it is a little triangle, and that triangle indicates that some heat has been added in order to go from reactant to product. Also notice that there are indicators of chemical change here. We see this solid powder, and then we see the formation of a gas. We see the condensation and the bubbles forming here in the test tube, as well as a color change. All right, in the next videos, I'll go on and talk about the other types of chemical reactions.